We're now working on the polyatomic naming structure for our ionic compounds, and this is module number 13, okay? So what we're going to do now is just look at ionic compounds with a bit of a twist. These are the ones that are a little bit trickier. So once you feel really confident with doing the basic ionic compounds, then you moved on to the transition metals where there's multivalent ionic compounds. Those were the metals that had more than one charge. This is the very last part of learning about ionic compounds, and it's with a compound made with something called a polyatomic. So what is a polyatomic? By definition, the prefix poly means many, atomic means atoms, and so a polyatomic ion is an overall ion that's made up of more than one atom. However, it acts like a single particle. So you're going to think about all these polyatomics essentially as a group of atoms that have an overall charge. And then we're going to just crisscross things down just like we normally do. But because they have more than one atom in it, it's not, for example, not just going to be nitride, which would just be nitrogen. Instead, we're looking at a group, and that group of atoms would be called, for example, nitrate, and that whole group of one nitrogen with 3 oxygens around it with an overall charge of 1 negative is what we call a polyatomic ion, and we're going to keep it together, and we're going to group it like that within the names. Now, if we were at school, we'd do a whole list of ones where we would memorize them and you'd get really good at it. So please, if you are taking chemistry next year, just be mindful of the fact that you're likely going to memorize a few of these polyatomic ions along with their charges, and everybody that took grade 10 science last semester already did that. So just make sure you really look at this module and pay careful attention so that you'll be right up to speed next year in grade 11. Okay, there's a picture down below from the textbook. This actually shows you what it looks like right here. So if you were to make a compound, and this is what we're going to do, it's called sodium phosphate. This is a group of atoms that together have an overall charge of 3 negative, and that polyatomic ion is called phosphate. So you would make a compound with sodium and phosphate. You, of course, would need 3 sodiums and 1 phosphate to make that neutral compound. Okay? All right, so here we go. Back to polyatomics. Let's look at some of these names. You're going to fill in this table. Nitrate is an NO3. Overall, it has a 1 minus charge, okay? -1. Doesn't matter for me this year if you do 1 minus or -1. You'll notice that I use that terminology kind of interchangeably. They kind of mean 2 different things, but for grade 10, don't worry. Hydroxide, that's an OH with a 1 minus charge, -1. Bicarbonate, HCO3 with a 1 minus charge. This is chlorate. Sometimes it's hard, right, when you're typing a chlorine because you need that little L. That is a ClO3. So 3 atoms of oxygen, 1 atom of chlorine. Together they have an overall charge of -1. Carbonate. Can you see what the charge on carbonate is? Yes, -2. Sulfate, -2. Phosphate, -3. And ammonia, there we go. There's one called ammonia. It has a 1 plus charge, so +1. Okay, have a look over here at some of the compounds. Again, they are all ionic. You've got a metal, and then the polyatomic is a group of those nonmetals together. You would always name the metal first and nonmetal second. So the first thing you need to do is go through this list, and it wants you to circle or highlight the polyatomic. There it is right there. Okay, NO3, that's a nitrate. Can you see the next one? That compound's called calcium hydroxide. There's my polyatomic, the OH. Can you see that that would read 1 ion or 1 atom of calcium and 3 polyatomics of hydroxide? The name of that compound is calcium hydroxide, but for this part, you're just writing in the name of the polyatomic. CO3, that's carbonate. SO4, sulfate. OH, hydroxide. NO3, nitrate. ClO3, chlorate. This one's a bit of a trick because it has a positive polyatomic, the ammonium, and then it has phosphate. Okay, so that's going to be ammonium phosphate as the name. Now that you've been able to identify the polyatomic, here's where you're going to be taking the formula to find the name, and then we'll do the same thing in reverse. If you're giving the name, write the formula. Okay, that's how all the questions are set up when we do our chemical nomenclature. Here we go. For the first one, Na2CO3. Okay, the first thing you do is you stop and you think, does the formula contain a polyatomic? Just look at the list. This isn't carbon, and it's not just oxygen. It's the group together, a CO3, we call that a carbonate. So yes, I know that that's going to be called carbonate. Okay? Then we also look at the metal. Is this metal a transition metal? If it's a transition metal, you're going to need to have the Roman numeral associated with it. But this is just sodium. It is not a transition metal. It's just in group number 1. So what's the name of my compound? This is called sodium carbonate. Metal first, non-metal that happens to be a polyatomic. And that's how you take the formula and come up with the name. Let's try the next one. Okay, so for the next one, you stop and you think first. The formula, look at that, contains a polyatomic. So I see an NO3, and I know the name of that is nitrate. Then I look at the metal, and I say, that metal is iron. You use your periodic table. You recognize that iron has more than one ionic charge because it's a transition metal in the middle. Which iron is it? Can you do the reverse crisscross rule and figure that out? Depends on how much practice you did in the first one, right? I know, and I'm going to look up the fact that the nitrate has a 1- charge. Does that make sense that if you work your way backwards, iron has a 3+ charge? So the iron that's in this compound is iron 3. Okay? If you need to do your work for that, here's how you would show that using your zero-sum rule. In this case, I just simply look it up that I know that the nitrate has a 1- charge. I know that there are 3 nitrates. Where did that 3 come from? Right in there in the formula. Because for this question, we're given the formula trying to figure out the name. There are 3 nitrates and 1 iron in this question. But I need to know what the charge of the iron is. So you're essentially solving for here. What's the charge? So the nitrate in this compound, because there are 3 things with a 1- charge, -3. How do I make this compound overall equal 0? Clearly the charge of the iron has to be +3. So if it's a +3, that tells me again that it's iron 3 nitrate. Okay? And again, the naming is specific. It's not nitride. That would have been if it was just nitrogen. But it's not. It's an NO3 with the 1- charge. This is a nitrate. Okay, reverse. Writing the formula if you are given the polyatomic name. Okay, so the first thing you'd say is, great, here is my compound that I need to figure out the formula for. The name of the compound is sodium phosphate. What ratio do these ions come in to give an overall 0 charge? The first thing I say is, okay, this is a polyatomic. I know that. I'm going to look up what the charge is. Sodium is just a group 1 metal, so there's nothing fancy with sodium. Now, if you remember all of your math and you can figure out that balancing without having to do the whole zero-sum rule, then you're allowed to do the cheater version, which is the crisscross rule. I use the charge to help me figure out the ratio that the ions are going to need to be in. If I have sodium with a 1+ charge and phosphate with a 3- charge, clearly I'm going to need a compound that has 3 sodium and 1 phosphate. Overall, I'm going to have 3 pluses, 1 thing with a 3-, overall 0 sum for that one. Okay, there's your math down below so you can see that. Notice that when you do this compound, and my notes have this, my solution set has a few extra things in the notes, so make sure you use that as you're filling in your notes. You don't need to put brackets around the phosphate because there is only 1 phosphate, and so you don't have to use brackets. You would only need brackets if you had more than 1, and that's the example that comes next. Okay. Here we go, last example, and then I'll let you work away. Copper 2 nitrate. Stop and think. Is this a polyatomic? Yes, nitrate is an NO3 with a 1 minus charge. Copper, do you know the charge on the copper? You sure do, because it's given to you in the name. It has to be given to you in the name. You can't just say copper nitrate because you don't know which copper ion it's going to be. Copper 2, let's do the crisscross rule. Cu2 plus, NO1 minus, crisscross them down, and here's your answer. Given the name, what's the formula? CuNO3 bracket 2. Do you have to put brackets around the nitrate? Yes, because this subscript tells me that there are 2 nitrates to every 1 copper. Okay, does that make sense? That's the last bit of polyatomics. Okay, and so we're going to do one more naming rule coming up in the next module, and then we're going to spend one full day, one module where we put all of the rules together. Okay, so the questions from homework on section 5.9 just deal with polyatomics. Okay, and then we'll start to put them all together and they'll be all mixed up. So you have to be able to recognize the compound to do the name and take the name and write the formula. And that's it for naming ionic particles. Good luck.